Okay, here we go at the problem solving portion of this problem. And I'm going to do this a little bit faster here just because I don't want to run out of time. And I thought I put some space in there. Okay, much better. And so let's get to work on this problem. So the first thing we want to do in this problem is draw the black box diagram. Hopefully the pen works. This is the top level black box diagram. Give it a real meaningful name, circuit, and we agreed last time that the output count is going to max out at 4. There's the count. It has a go signal, and it's run by a clock. Okay, there's our top level. That's always the first step. Gives us the interface, helps us do the rest of the problem. Okay, so we listed the modules in the last video, so let's just draw them right now. First we got the RAM, and then we have a counter. Pretty much anytime we have a counter, we're going to have to clear that counter, so we'll do that. We'll have to control when that counter counts. It's an up signal in this one, and this is going to be 32 bits. I'm sorry, it's 32 location RAM, so I need a 5-bit counter. There's the address there. We'll include a write enable on this thing. Don't really need to, but it's good enough. Okay, so what I'm going to do on this thing is add an extra register in this thing. And I'm going to put this register down here. And I'm going to give it a load signal. And a count. I think I need a load signal on this thing. These are 8-bit values, and then I'm going to be comparing these things. I'm going to be comparing the current value of the RAM, which is this one, with the past value, which is going to be stored in that register. And so this is going to be A, B. I could do this different ways. I like doing it this way. And what I'm interested in here is when A is greater than B. I'm just going to call that GT. And lastly, I have another counter sitting out here, which is CNTR. I'm going to give a up 2 on this thing. Signal. This is the output count, which we agreed to be 4 up here. Looking good. Trying to think what else I need here. Certainly anytime I'm counting stuff, I'm going to start it at 0 and put in some extra stuff in here to make it look better. And I think at that point I'm ready to crank the circuit out. Now the issue in the circuit is, I get really used to using 2 states for these things. There's actually 3 states in it. If you sit back and think, okay, look, I got to get that first value into this register before I compare it with the second value. And that being the case, actually I should put the RCO in here, and which means I should also include FSM. So yep, I forgot, but not a big deal. I remembered, and I came back and filled it out. Okay, I remember this left side here are the status signals. The other side is the control signals, and I have a clear. Certainly running out of space. What else do I have? An up 2. I think I have a double write enable over there too, and I think that's it. But I have a load also. Okay, I think that's right. There's a lot of control signals there, but not a big deal. A lot of them aren't used in every single state, or they're very simple, so we'll worry about that in a second. But I think it's right. If it's not right, I don't really care. I'll go back and fix it later. I don't have to get it right the first time. I just have to eventually get it right. So I'm winging these problems. I don't have a solution sitting here. And, it's just the idea is make it work by the time you're done. Okay, so the 3 things that are happening here are, number 1, I'm waiting for a go signal. Next thing I'm doing, I'm preloading this register, which I'm going to spend a state doing, and then I'm going to just step through all the other locations in the RAM. Okay, so I'm going to have a 3 states on this one because basically I just kind of described the 3 things that this circuit's going to be doing. And so let's draw them here. I kind of did leave myself a lot of room, but that's okay. 1, 2, 3. Give it some values, weight, load, count. Okay, so in each of these states here, I have to account for all these variables. So I'm going to pretty much say we're not writing anything ever. So I'm turning the write enable off. So I've taken care of that one. And so next thing we need to do here is let's do this a state at a time. In this state here, I'm waiting for a go signal. If I don't get a go signal, I stay there. I could make this into a 4-state state machine, but I'm going to implement it as a Mealy machine. So this clear input is a function of the go. The clear output is a function of the go input, which is, makes it into a Mealy machine. Go clear. Looking good. So I get a go signal, everything gets cleared, I go into that first load state. Other than that, I can step through this thing and say, we already got WE. I can turn both ups off. And what else do I have in there? I can turn the load off. This is pretty much a do nothing state. So in this preload state, what I'm going to be doing is, once again, I have to account for all these variables here. So I'm going to say, I'm not clearing. What else do I have? I'm loading. So this is the load signal here. I, by all means, need to load that value every single time, specifically the first time. But as far as the other signals go, I am counting up, but I'm making sure that up 2 is not going to turn on, because up 2 is not going to possibly. This is up 2. That's the count of how many times I find these things in ascending order. That's not going to happen until I get the register loaded, and I'm not going to get the register loaded until at least until I arrive in this next state. So the transition from the load state to the count state is unconditional. Don't need to worry about anything, and I've got all 5 signals in there. I'm pretty much going to have the same 5 signals in here with one difference. I'm still loading. I'm still counting up, but now up 2 is equal to greater than. So this greater than is going to tell me for that about the condition I'm searching for on this thing. Okay, and I'm going to continue here until RCO turns on. RCO turns on. I'm going to go back to the wait state. Here's the RCO turned off. And I believe I'm going to look at this. So I got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I got all the signals accounted for in every state. Remember, this is a don't care, which means I don't really care what the state of those signals are in this state diagram. That's why, or in this state machine, that's what the don't care means. I don't care about the inputs. Essentially, in this input here, I have an RCO, of course, but I actually don't care about the go signal. In this one, I have a go signal. I don't care about the RCO. So anyway, that's it. I'm going to clean it up a little bit. I'm going to say up equals 1 is increment, up equals 0, hold, and I'm going to say for both counters. Okay, that works. And I'm going to say also clear has precedence over up in both counters. Okay, and I'm trying to think of what else I need to do here. I think at that point, I'm going to call this done. I'll stare at this for a minute, see if I forgot anything. Looks good. I don't think I forgot anything. I'm going to call this problem done.